The IoT gateway can be used to read electrical parameters from Modbus enabled meters and can be sent to mobile application or Arduino dashboard in a computer. This will be very useful to know the daily, weekly, and monthly consumption of your electrical energy usage. By modifying the programming, it can be used to send notifications to know the daily usages of your electricity usage. We can also interface a heavy-duty contactor to isolate the electricity if it exceeds a predefined kilowatt or units. I'm using a single-phase electrical meter made by Select. The meter has inbuilt Modbus integrator and two-wire RS485 communication interface to connect any Modbus gateway. The IoT gateway, which reads the data from the meter and will share to a mobile application or Arduino dashboard to know the electrical usages. The project will use to measure four parameters: voltage, current, kilowatt, and kilowatt hour. The program can be expanded to read many other electrical parameters, which will be delivered by the meters. But at present, I have limited to read only four parameters. What is Modbus? Modbus is an open protocol, meaning that it's free for manufacturers to build into their equipment without having to pay royalties. It has become a standard communication protocol in industry and is now the most commonly available means of connecting industrial electronic devices. It is used widely by many manufacturers throughout many industries. Modbus is typically used to transmit signals from instrumentation and control devices back to a main controller or data gathering system. For example, a system that measures temperature and humidity and communicates the results to a computer. Modbus is often used to connect a supervisory computer with a remote terminal units (RTU) in supervisory control and data acquisition system. How does it work? Modbus is transmitted over serial lines between devices. The simplest setup would be a single serial cable connecting the serial ports on two devices, a master and a slave. The data is sent as a series of ones and zeros called bits. Each bit is sent as a voltage. Zeros are sent as positive voltage and ones as negative. The bits are sent very quickly. Data is transmitted in 8-bit format, one bit at a time, at a baud rate ranging from 1200 bits per second to 1015.2 kilobits per second. A typical transmission speed is 9600 baud rate bits per second is selected in most of the devices. Typical Modbus RTU is an RS485 standard. It can support up to 4000 feet. That means 1200 meters is generally accepted as a maximum length of communication cable. Now we can see how can we read data from a Modbus live devices. We have to define 5 parameters in the master controller for IoT gateways: slave ID, function code, register address, register count, and error checking. And what is slave ID? Slave ID or device address is the physical address of the devices to read or write data to a device. The slave ID can be configured in the configuration menu of the Modbus devices. And we can define any number from 1 to 247 by using the configuration menu. And function code. Function code in a Modbus device is a specific code which is used in a Modbus request to tell the Modbus live device what type of memory. There are different memories available in Modbus live devices, that is a holding register, input calls, input registers, etc. to access and what action to perform on that memory, read or write operations. And next is register address. Modbus data is read and write by registers, which are signed or unsigned 16-bit integer. There are 4 registers referred in a Modbus device: coil or discrete output, address ranges 1 to 9999. Discrete input or status input, address range 10,001 to 19,999. Input register, address range 30,001 to 39,999. Holding register, address range of 40,001 to 49,999. And next is register count. which is the length of the register. Modbus data is often read and write as registers, which are 16-bit pieces of data. If a 32-bit integer or floating point is required, these values are actually read as a pair of registers. And next is error checking. Standard Modbus serial networks use two kinds of error checking. Parity checking, even or odd or no parity, can be optionally applied to each character. Frame checking, LRC or CRC, is applied to the entire message. This is the meter documentation. From this, we can get all the values to be configured in the master controller to read value from the meter. Example, here, this is here, the slave ID is defined. See, this is the slave ID, 1. Factory default ID is 1. And we can adjust, we can change the values from 1 to 255. That means any value can be added in the meter. So that will be the slave ID, which is to be configured in the master device. And these are the address registers. So readable parameters for communication, length of the register, it's 2. And data structure is float that we are programming in the sketch. So here, these are the addresses. So register addresses. Here it is starting from 30,000 and this is the hexadecimal address. And this is the parameter. If we give 30,000, the master will read total active energy. And if it is 30,002, the master will read import active energy. So like this, we can configure any address register values to read the corresponding data. That means for reading active power, it should be 30,014. So it will read active power. And 16, it's reactive power. And 18, it's apparent power. And 20, it's voltage. And 22, current. And others also there. But since the addressing scheme is based on 0, here you can see it's 30,000. That means it's a 0 based addressing scheme, 0 into 0, 0. So we have to add 1 to read the data, particular data. That means to read active power, we have to define an register address of 14 plus 1. That means 15. If we give 15, it will read active power. If we give 17, 16 plus 1, it will read 16 plus 1, it will read reactive power. And if it is 18 plus 1, 19, it will read apparent power. If it is 20 plus 1, 21, it will read voltage. If it is 22 plus 1, it will read current. And if it is 24 plus 1, it will read power factor. Like that, we can configure, we can define any value, um, any address. But since this is structured in zero based architecture, so we have to add 1. And I will show you one more thing. See, this is the parity. Parity bit is here. Now we can configure 3 options: none, odd, and even. So we have to define, if we have configured none in the meter, so in the master programming, master code, we have to define none. And if we have configured odd parity, then we have to define odd in the sketch, in the coding. And if it is configured even in the meter, of course we have to define even in the program sketch. So all the information can be get from the instruction manual of the device. This is the meter which I am using at my home, and it can be used to measure many electrical parameters such as voltage, current, frequency, power factor, and active power, reactive power, and active energy, and all the almost all the electrical parameters can be measured with this. and the measured data can be transferred to any third-party system over the serial communication. This is the serial communication which is running on RS-485, and the protocol which is using is Modbus RTU. So Modbus RTU is open protocol and it can be integrated to any third-party systems. So the meter here, the RS-485 is connected to the Modbus communication interface, and that will transfer all the information to IoT. This is the various parameters, various function of the meters, and these are the parameters. We can go to different options by using the switch, so we can get all the parameters from here also, from the screen also, as well as it will be transferred to our mobile or laptop by using the IoT gateway. And kilowatt is measuring now, and reactive power and active power and voltage, current, power factor, frequency, and kilowatt hour. From this we can calculate units also, and by using some kind of calculations, so we can we can calculate the tariff also, and monthly bill of our consumption also can be calculated. This is the function of the meter. This is the hardware setup which is used to read parameter from the Modbus meter, and this is the serial communication cable which is connected to the meter, multi-parameter meter, and this is the serial interface connection of the meter, and the meter has a Modbus protocol integrated inbuilt. That means all the parameters from the meter can be transferred to the IoT gateway unit through its two-core cable. And this is standard ESP32 demonstration board, and this is RS485 transceiver. The transceiver has in major two ports are there called RO and DI. RO is the receiver output which is connected to the pin number 18 of the ESP32, and the DI drivers input which is connected to 19 of the ESP32, and there are another two terminals which is called DE and RE, driver enable and receiver enable, and both are connected to pin number 21. And in the software, in the coding part, I have added a library called ESP software serial. That library will handle all kind of communication between the ESP32 and the RS485 transceiver. I'm using Arduino Cloud as the IoT platform. The values which we are getting from the meters will be displayed in the Arduino Cloud dashboards. So I have defined four parameters: current, energy, power, and voltages. All are float values. And we have to include a library called the Modbus RTU.h. That means the library is used for communicating to the meters and read the data from the meter. So that is why I have included Modbus RTU.h. And we have to define the speed of the communication, serial communication. It is called baud rate. Here I have defined a baud rate of 9600. That means the speed of the communication between the meter and the gateway. And in addition to that, to read the data from the meters, we have to define other two important values. Like one is the slave ID. That means the meter will have a hardware address. It is called the slave ID. We can connect the multiple meters to the gateways. So we have to define slave IDs. That means if one is defined for 1 meter, another one will be 2, 3, etc. Define the address which we are reading. That means we have to get all the data from the meters in individual registers. So the register address will be available in a format called address list. So it will be here. This is the meter documentation. The meter which I am using is select. So select documentations are here, and you can see the meter address list. So these are the address list. 30,000 means this is the decimal value, and it's a equivalent hexadecimal value also mentioned here. So we can get the total active energy. If we define this value, we will get total energy, active energy. Here I have defined four values. Voltage is here 30020. But here the values are structured in hexadecimal. So when we are reading, we have to add 1 to the hexadecimal value. So it will be 30021. So here I have defined in the program, I have defined 21. That means the voltage value from the meter. And the value is the variable which is used to store the value from the meters, because we have to receive 2 bytes from the meter. So I have defined 2, and the CB is the the Modbus call between the meter and the communication interface. When we get the value, it will be saved in a variable called voltage. So if we give these parameters, when we get the value, it will be stored in a float variable. So the float variable we have defined here in the beginning of the program. And like this, we have to define other parameters also. Current also will be the same way. And if we need to add more parameters, if we need to get more parameters, we have to define its address. And after that, we can go to the cloud part of it, dashboard of it. So this is the dashboard. Now we can go to dashboard. So this is the dashboard. Energy meter. Now current is, we are getting the current value, active energy and active power. And its chart also will be displayed here. So from the chart we can get the history of all the values. And it's a mobile application also available. So we can install the mobile application from the Google Store or Apple Store, and we can view all the values in the mobile application. This is the mobile application view, and this is the exact replication of the Arduino dashboard. We don't want to configure any gauges or history chart in this application. So whatever we have configured in Arduino dashboard will be called and will be displayed here. The application can be downloaded from Apple Store in iPhones and from Play Store in Android mobiles. We don't want to do any kind of configurations in this. You can expand the project to display more electrical parameters, and also can be used to display the unit and the tariff by modifying the program. Thank you very much for watching my video. In the next video, I will come with a new project. Thank you very much again.